Good afternoon. Sorry I couldn't be joining you guys today, but I wanted to give you guys a video for day 7. So we're going to talk about a couple things here. Remember, we're going over more regression equations. So the regression equations we're going to get are going to be beyond linear. We're going to get into some exponential. We'll talk about how to kind of recognize that from the graph and also the table, kind of get an idea of when to use each. So number one, we're kind of tying everything together here. How do we create a scatter plot? So remember, the scatter plot is the graph. So make sure we're identifying which is the x and y variable, the independent versus dependent. We want to make sure we pick our scale. And one thing we can do is actually type your information into the calculator, let the calculator make the scatter plot, and then you can kind of use their scale if you're not sure. Just make sure you're consistent. You're always counting by 1s, 2s, 5s, 10s, and it's always spaced apart evenly, okay? If you're stuck on the scale, just pick the highest and lowest numbers and kind of figure out where you should start and then how much to count by to make sure it fits, okay? If you skip numbers on an axis, make sure you include the break. Remember, that's a little lightning bolt, okay? And then we are going to graph each set as a point, okay? You don't have to use, they changed the, how we're going to do this. You don't need to use the box anymore, so don't worry about doing this part. Just use the point and the dot there. And then we're going to have to put in our information in the calculator to create the scatter plot and then also find the line of best fit. Okay, and then draw that in for our graph. So remember, we're going to start by making lists and spreadsheets. Make sure we name our top categories, whatever you want to call that. Make sure it's a short word at the top, and then enter your information in. And then to view your scatter plot, you're going to go to home screen, and you're going to insert or control doc, insert the data statistics, and then just make sure you assign, okay, your variables down here to the whatever your variables are to get that going. Now you can see on this curve that this isn't like a straight line. It actually makes a curve, and so that's how we can kind of tell if we're going to use a linear or an exponential regression there. All right, now to insert your regression, you're going to go to menu from here. Choice 4 on the graph is analyze. Option 6 is regression, and then you can either pick from the ones we're going to use is the show linear, so that's the mx plus b, and then down here at number 8 you can see that they have an exponential regression, which is the other one we're going to use. Okay, so it's either one of these two, and then once the graph comes up, it'll have your equation. You guys can see this is modeled by this, and then we can also pull up the residuals if we'd like, but we don't have to. All right. And then we're going to go down and let's take a look at number 1. So when we create a scatter plot from the following data values. Oh, and I don't know why this shouldn't be there, but it is. Just so that we don't have to worry about that. Okay. So number 1, we can see our data. So let's go ahead and type that into our calculator. So I'm going to go type it into mine. Why don't you pause here and type yours in, and then we'll get it back together when that's done. Okay, so we have that information in here. We can now go and view the scatter plot by once again going Control, Document, going over to Data and Statistics. We're going to choose the X variable for our X-axis, the Y variable for our Y-axis. We can see that these are actually kind of forming a line, so it looks like we can use a linear regression. So Menu, Analyze, Regression, and then Linear Regression, mx plus b, and there's our equation. So y equals 2x plus 8. Okay, on this one, okay, we would only be asked to do the residuals if we needed to for this graph. So remember, once you do the regression, when you go back to analyze, you could use residuals and show the plot from here, and you can see that these are actually forming a perfect straight line. So we know the correlation coefficient should be, if we needed to, 1. Okay, so we're going to start counting. You can see the scale at the bottom starts at 10, right? And we're going to have a break here because we're skipping, going all the way up to 18. And it looks like they're counting by 2s in the y-axis. It looks like they start at 12. So we can do the same thing. So we're going to go, okay, put a break on our axis. We're going to start counting here at 10. So 10, 12, 14, 16, 18. And if you wanted to, you could even space these out more. You could skip one. So, we could call this 10, 12, and keep going that way. It's up to you. Okay. And then we're going to start here as well. We also have a break on this axis. So another lightning bolt there. And then starting at 12, 14, 16, 18, 20. We need to go all the way up to 28. So just keep that in mind for ourselves. The other thing we need to do is we need to label. So if there were titles here, we would want to write those underneath. It's just X and Y. So as long as those are labeled, we're okay. And then we're going to go put our points. So the first point happens at 10, 12. We're going to go ahead and put a dot there. 12, 16, put a dot there. 14, 20, put a dot there. 16, 24, and 18, 28. And then to draw the line of best fit, we know that from our calculator here that it just goes right through those points. So take our line, and we'll just start at the origin and draw. Actually, we start at the origin because we're skipping numbers. So even though it looks like we're starting at 0, 0, we're really not. So be careful that you're not doing that. We just want to transfer that line. Make sure we're drawing it through all the points. And there we go. Okay. And there's our line. And if we wanted to, we could label the equation. It's just y equals 2x plus 8. But we don't have to label the equation. It's just an option. So what is the equation of the line of best fit? Y equals 2x plus 8. What type of regression best fit this graph? This is linear. And also, we know it's linear because when we did the option for a residual, right, it was right on the line and it didn't make that U-shaped pattern. How did you know? Is there a way to check this? So we could just say use the residual graph to make sure there is not a U-shaped pattern. Okay? All right, let's see if you guys could try this one on your own. So what I'd like you guys to do is make a scatter plot for these. Go ahead and put that down first. And then also do your linear regression equation. What equation do you think is the best for this one? So scatter plot first, and then we'll talk. Okay, so we've kept our scale. And apologies for some of the words are eaten up here. But we're only counting by ones on the x-axis. We don't need to insert any numbers here. We just let it be just blank so that it's assumed to be counted by 1. And then I counted by 1 on the y-axis because it has 15 lines. So we can just label, I label every 5 here. And then we graphed our points getting this graph. So if we haven't done that, do that now. Okay. If you look at these points, what curve do you think is going to be best here? Right? What curve do we think is going to be best? And hopefully you can kind of see that this kind of looks like, right? The graph kind of looks like a parabola. So a quadratic regression is actually going to be probably the most appropriate. So let's go ahead and do that. Now you won't have to do this on a test or a quiz, but we can kind of use the points to determine what's going to be best. So let's go ahead and type it in your calculator. Okay, and then remember we're going to go Control Doc, add that data statistics, assign our variables, X and Y, and then we can see that that pattern has that curve pattern. So exponential wouldn't necessarily be great because it's only going to go this way. And you can see that as we do analyze and regression, if we choose exponential, you kind of see that this line, even though it's an exponential, looks linear. It doesn't look like it works very well. And if you go to the residuals, like we did before, you can see that there's like a curved pattern, which means it's not a good fit. So even if you check the pattern on any regression, it'll tell you whether or not it's a good fit. So if we instead choose and Control Z to undo, the quadratic regression, you can see that this does model those points. And if we check the residuals, okay, it sort of has a pattern. So I wouldn't necessarily do it in this method, but it's not a perfect U shape. So that's kind of the idea here. And we can see that it actually does model them really well. Okay, so this is going to be our equation. So 3x squared minus 11x plus 11. So we're going to go ahead and write that down. So y equals 3x squared minus 11x plus 11, and then quadratic. Okay, for number 3, let's just answer the questions without doing the scatter plot since it's kind of jumbled here. So let's type in this information. So go ahead and do that on your calculator now. Okay, once we have that typed in, we're going to go ahead and enter our scatter plot on our calculator. So data statistics, choose our variables, so x and y, and then what pattern does it look like the points are taking now, right? And here, it's not making the U shape, it's going up on that curve. It kind of looks like it's an exponential. So if we go to Analyze and Regression and choose Exponential, you can see that that sort of does model that curve. It's not great, it's not perfect, but it does a pretty good job. And if we check out the residuals, we got kind of a scramble here, right? And if we, instead of doing, just to show you guys, if we did a regression that was linear, mx plus b, and we checked out our residuals, right, we have that U-shaped pattern, which means linear is not appropriate, okay? So we know we're going to choose an exponential regression here for that reason, okay? And then we're going to round our equation. Let's go to the nearest thousandth here. Does it say otherwise? It does not. So we'll do the nearest thousandth. So y equals 0.664 times, and then 3.8489, 3.489 to the x. Remember exponentials, okay, have that, y equals ab to the x format there, okay? And how did you know? Is there a way to check that this is a correct? How did we know, right? We modeled the shape of the points. To the shape of points. And verified using the graph of the residuals. Okay, so let's have you guys try number 4 here. See if you can fill all of this information in. So let's see if you can do your scatter plot. Okay, so what is your scale going to be? So notice I'm going from 1 to 61. So I have to split this at the y-axis from 1 to 61. And I only have what? 2, 4, 6, 8, 10, 12, 15 spots. So I'm going to have to count by some number. Maybe we'll count by, what, 5, if that's appropriate. And since we're starting at 1, we're not going to skip. So see if you can finish this one up. So pause it here. Let's see your scatter plot. Okay, so once again, because we just have x's and y's, we don't have to label the names of the variables on the left and right here on the axes, but we're just going to plot. So at 2 we're at 1, 3, 5, right? 4, 13, 29, and then 61. So what does this look like? Does it look like a line is going to be appropriate, or what type of equation? So hopefully, right, we put down exponential again. And then remember, we're going to go ahead and go control document, data statistics. We'll assign our variables here. Okay, and then we're going to go to menu, analyze, regression, and then we're going to go down to exponential and pick our poison. So once again, we're going to round it up. This is 1.90 because the 9 is going to round up, and then 2.71. Let's go to the nearest tenth. So we'll go y equals our 100th is 0.0 0.19 times, you can use parentheses here if you want. So parentheses. And then we have 2.71 and then x. Okay, and if we wanted to draw the curve in, we can kind of see how that's going. So it kind of goes underneath the second and third. So it's sort of curving like this, and then it goes kind of through here and then above this. So curve looks something like that. Doesn't have to be perfect, but that would be our line of best fit if we needed to draw it. Okay? All right, let's try the last one here. Same thing. So let's see what you guys can do. Okay, so once again, after we've done typed it in our calculator here, we're going to go Control Document for ourselves, Data and Statistics, choose your variables, and then what do we think is going to model best? And this is interesting. I think this point should be way down there. We forgot a 0, that's why. So on this one, remember we now edit this so we can see the problem. It's 0.065. When we go back here, it'll have fixed itself. It's really close there. And what do we think is going to model best here once again? So we think it might be a line. Sure, let's check line. So we'll go analyze regression. Maybe linear would be best. Okay, so if we check out the residuals, oh, we got a U-shaped pattern, so that actually doesn't work. Okay, so maybe we should try exponential then. Check out the residuals. What do we think? Sort of random, right? Not really a U, it's kind of bouncing up and down. So this is the one that we would want to pick, okay? Usually, remember, once again, we're using the residuals mainly for the linear, whether a linear is appropriate, okay? So if it's not, we're pretty much choosing exponential. Okay, so we're going to go ahead and fill this information in for ourselves. So let's see if you guys can do the scatter plot, and we'll go from there. I'll tell you what, we'll do the scatter plot. We'll just treat this as 1 on the bottom. So let's just treat this bottom line here as our x-axis. All right, I'm going to do this in blue. We're going to treat this as our x. So let's just pretend that's x. And there's our y value. And since we're pretty small, maybe we can count by a smaller number, right? So what about I think 0.1? Sure. 0.1, 0.2, 0.3, 0.4, 0.5. The calculator used 0.15, even smaller, right? And actually it was like 0.05, I think, going there. So we're at 0.05, 0.5, so at 1, at 0, actually we're right here. 0.25, 0.125, and then 0.06125 is right about there. So that's what our graph would look like. We have our axes labeled. We need to put an X there. The line of best fit, once again, is y equals, we have our equation, 0.5, 0.5 raised to the 0.5x. And what type of exponential? We'll just put it here, is exponential. Okay? And I'd like you guys to try number 6 for homework. So go ahead and do this one, and we'll go over this tomorrow. Have a great day, guys. Tomorrow is going to be a review day, okay? And then Friday, we're going to do a little review, and then Monday is going to be our test. We'll see you guys then.